Let's record it again and continue where we were. Let me know if you can't hear it.
Puppet Super Bowl ad. Another offers to drive a single candy bar to your door for free. None of it is sustainable, but Wall Street doesn't care until March of 2000 when the bubble pops, when the Nasdaq loses most of its value and thousands of companies vanish overnight. Sadly, a generation of young men on that Mama Coco have to move back in with their parents, but a few survivors manage to crawl out of the wreckage, the biggest being two guys named Larry and Sergey who write an algorithm they call PageRank. The idea is to treat every hyperlink as a vote, then weight each vote by how important the linking page is recursively, so a link from a famous site counts for far more than a link from your blog. They take this idea, then wire it up to an ad auction, and turn it into the most profitable money printer ever built. Meanwhile, the browser continues to evolve, and some call it Web 2.0. Under the hood, a trick called Ajax lets JavaScript quietly fetch data in the background with XML HTTP request and update a page without a full refresh, so a website can finally feel like an app instead of a pamphlet you need to keep reprinting. And now it's 2007. Civilization has peaked, but we don't know it yet. A guy named Mark gives everyone their own printing press with a built-in backdoor for his shareholders. Around the same time, a guy named Steve pulls a rectangle out of his pocket. It's a phone that runs a real browser with an always-on cellular connection. The information superhighway escapes from our desk into our pockets. And the good news is that we no longer need MapQuest to navigate around the world, but the bad news is that it'll eventually rot our children's brains. And that brings us to today. When you visit an average website, you must first accept cookies, decline the newsletter pop-up, dismiss the app download nag, wait for 10 megabytes of JavaScript to download before you can even read the content that probably wasn't even written by a human. Thankfully, two guys named Sam and Dario ingested the entire internet while tricking the rocks into thinking harder, and now they're renting it back to us at a premium. But while some companies are filling the internet with slop, others are trying to clean it up, which brings us to CodeRabbit, the sponsor of today's video. AI.
Okay, so that was the Farshare video. And now let's get started with coding. Okay. So as you all know, we're working on, okay, wait. Caden, Adam, Nicholas, James. Okay, nobody needs GitHub repo access, right? You guys already have it. So last week we were working on Project 13, right? Stock AI Analyzer. We have our, can you just give us link, share link? Yeah, I will also do that. So let's just do that right now. Anyways, I have the light share link in the chat. So we have our virtual environment. So this is our Python instance. We activate it using this source and then the location of that VM virtual environment file folder. So it's this on my computer and then bin/activate. It's different for your computers because you're not a Mac, but it should be similar. Next, we have we're mainly working on the data client right now, right? So we already have our get async client, close async client, get USD to CAD, accept, get ticker info, get current price, batch, and then get advanced metrics. And now we need to work on get macro data, I mean news, and get ticker news. So these two will be similar to get historic. No, it'll be a bit different because here we'll use HTTP GET requests since it's APIs. It should be similar to something like this. HTTP.get.json. Anyways, we'll work on that. And then I'm thinking, what do we do? We did data client, and that's all we did. Oh, and PDF reports. Okay. Let's continue with the data client. First, let's do get macro news, and we'll do Kden. Whenever you're ready, share your screen. Let me actually enable share. Okay, you should be able to share now. Okay, take your time. After Kden, actually before Kden, Adam, can you share your screen? We'll do Adam first, and then Kden.
Okay.
Thank you. Bottom right. Okay, we can do get ticker news first. So fetch the latest news articles for a specific ticker. We're gonna do get ticker news first, the bottom one. Yep. And then, so we grab the latest news. We return a list of the dictionaries with title, publisher, and link. And we want to limit the result to limit amount of articles. So we're going to do a batch request. So delete the pass. You can also delete your code here. Up to you. You're going to do try except block. So try. Nope. Delete the except. Try. Nope. They have to be in separate lines, but let's do try first. Do try and then colon. Scroll down. Enter. Stock equals YF dot capital T ticker. No, capital T. That's a class. And we pass in ticker, lowercase. Next line, uh, tab, return, space, and it's going to be a list of dictionary. So do list, enter, dictionary. So it's a curly bracket. No, remember that dictionary is a curly bracket. So delete that dictionary. I'm telling you that the curly bracket is what a dictionary is. Okay, I think someone else is using this, which is why it's going up. But there's nothing we can do about it. The better instance is just you guys using the GitHub instead of the LiveShare, but whatever. Inside the dictionary, you're gonna do a string, so it's the quotation mark, title, outside the string. No, 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 no. That was good. That was good. Oh my gosh. It's switching so much. Colon. No, colon, colon. So I get why you did it that way. It's because you're thinking of it as a list. But dictionaries are different because they have key and value pairs. So for that value pair, you're going to delete the quotation mark. It's going to be a bit different because we're grabbing stuff from that stock equals yf.ticker. YF is Yahoo Finance, and Yahoo Finance is a library which has a class named ticker, which when you pass in a ticker, then it gives you all the information about that stock. Now, what we're trying to do is that this stock has a dictionary full of information. So what we're trying to do is return a concise version of that. So we're going to return a list of a dictionary, and inside that dictionary, we're going to extract that title, we're going to extract the publisher and link. So for that title, you're going to do a dot get. So what it does is inside of this, we're going to get the title, we're going to get so to get that title, you're going to do a function. So it's a circle bracket. Inside that circle bracket, you're going to give it a string and it's going to be title. And then to the right side of it, we're going to do comma. No, inside the circle bracket, but right side of title, you're going to do comma and then another string. But the string is going to be empty. So what it's saying is if we didn't get anything with the thing inside the stock dictionary called title, then just give it a empty string. Comma. We're gonna now do the publisher. So no, delete that. It's outside the circle bracket. Yeah, because now you see in that dictionary we have the title. Now we're gonna do comma and then we're gonna do the publisher. String publisher, right? You can't just do publisher, right? Because the dictionary's key can't be a variable, and what you just do with just publisher is not valid syntax. It's just not code. So you're gonna want it to be a string of publisher. And remember that for a dictionary, you need a colon, right? And I think you did it outside the dictionary. You don't want that. That's the list. Yes, in the dictionary, the publisher key has a value. This value you're gonna do a.get. You'll see why it's a in a second. But a.get, the circle bracket, and it's going to be publisher, comma, and then empty string. No, no, no. You're right. Publisher, colon, a dot get, circle bracket. Inside it, you're going to do the string. Look at the title, right? You're going to do publisher, comma, empty string. And then do the same again for the link. Thank you, James. Yep, good job. Yep. Okay. Now, now you're gonna find out why we have the A. So outside the dictionary, but inside the list. So right. Yep, right there. You're gonna do for A in. So it's gonna be an inline for loop. So you're gonna do for A in stock.news. That's the right idea though, range. But this is a bit different because we want to use how long the stock is. So you're gonna do stock.news square bracket. Inside the square bracket, you're gonna do a colon limit. Yep, good job. So do you know what that syntax does? This colon limit. Basically, stock.news is gonna be a list, I think. Can you hover on the news? List, right? So it's basically a list. Now you're gonna index it. You're gonna want it from the start. So there's nothing at this. So the start to the limit. And that how you do it is colon. Nothing colon means everything up until. No, don't write nothing. I'm just saying that there's nothing there. Usually you put like 0 or 1, right? Here we want to start from the beginning. So just nothing colon to the limit. Make sense? And then let's say somehow we have like stock.new. Oh wait. Let's say that is stock limit 1 or 2. What this does is it basically skips. So if it's like 0, 1, 2, 3, if we index it like this, 1, 3, I don't know if you guys see this, but it basically says from the start up until 5, so ignore the 6. We want to get everything with 2 step. So we're going to get 0, we're going to grab 2, we're going to grab 4, and that's the end. So it's 0 to 4. But yeah, that's basically how indexing works. Anyways, mm, okay, that line's good. Then do next line, backspace. Now we need every try needs an except. So you're going to do except exception, capital E. Sorry, except is not ACCEPT. is EX, whatever. Yep, like that. And then you need a colon at the end. Enter, you're gonna do return. Same format as before, but different in a way. You're gonna do a list, so a square bracket, and inside the list is a dictionary. Inside the dictionary is a string title. You need a colon, but different from last time, you're gonna do a F string, so F and then quotation. The reason being this is the case where there is no news. So inside the F string, you're gonna do could not fetch news for could not fetch news for. You're gonna do a square curly bracket. Inside the curly bracket, you're gonna do ticker. Now you're gonna do another thing inside the dictionary called publisher. So to the right of the quotation mark, comma, another string, publisher, colon, and then string, colon outside the quotation mark, right? No, no, no. What? No, go back. What? No, go back. First, why do you have a random colon there? And then second of all, exception, you have a colon inside the string. You don't want that. You want it outside the string for publisher. But not the go down. What we were just working on. Yes. Delete the quotation. Delete the space. No, but you're missing a quotation now for publisher, right? No, no, no. Publisher should be the string. No, no, you don't have a like you're missing a closing quotation mark. Yes, and then do a colon inside the dictionary because publisher is the key, but this key doesn't have a value to it. So we need to add a value to it. But you're doing a colon on the dictionary itself when it should be inside it, when you should be doing it for that key, right? So delete that colon. Yeah, yeah, yeah. And then do a string. And inside that string, you're gonna do system. Yeah. Okay. That's it. You can stop sharing. So really, you guys should try and learn all these Python basic types, right? Because I don't think you guys should be really knowing the what a dictionary is like, or how to like index, how to do an inline for loop, how to do try and accept blocks, etc. Right? And then next, Kaden, can you share your screen? Let's do get macro news. Okay. So you're gonna fetch the general market news, try the Fin hub first. So I'm reading the doc string, right? Try the Fin hub first if the API key exists, or else you want to do news API. And then finally you want to return a single fallback, so like a exception. And then you want to and then each article should be a dictionary with a title, publisher, and link. So just like before. Okay, so do if we're doing the fin hub first. So if all caps FINN hub underscore key colon. You're gonna do try and accept block. So try first, try colon, enter not accept, right? You're gonna do response, so res or response or whatever. Also, a reason why you don't want the accept block there, accept should be on the same line as try. Anyways, response equals underscore HTTP. So if you want to know what HTTP does, I'm pretty sure. Yeah. So if you go to the way top, you'll see this HTTP equals HTTPX dot client. Basically, it's another library for it. HTTP requests, we need it for GET requests to this API. Basically, when you guys use API keys, or I mean APIs, you're gonna want to do GET requests, POST requests, what else are there? Put and delete requests. All of those you need to do it with HTTP clients, and this is one of them. Now, if it's for like JavaScript, then you're gonna use Axios or some fetch function. Otherwise, in Python, you usually just use random HTTPX. Anyways, oh yeah, there's also some of other ones because Python has some different libraries or frameworks. One of it I know is like Fast API or something, but anyways, we're gonna do HTTP dot get, right? We're gonna do a get request, and that's a function. Uh, okay. I think I'll just paste in the URL. Usually, where you guys want to get these URLs from is this is when you guys have to look into the documentation, right? So if I pull it up, briefly stop sharing your screen. Basically, when you guys do like, I don't know, web applications or code, you guys are gonna want to look for the documentation on whatever your APIs you guys use. API documentation. Show. Okay, why is this not? My Wi-Fi now? Okay, let's try the other one. Use API. So endpoint. Why are these broken? Okay. Basically, it's just looks something like this. Why am I so zoomed? Okay, whatever. Basically, this website is not loading properly. Might be due to my Wi-Fi or something. But anyways, you guys should see something like this. So what this is saying is we have this API where for GET request, you're gonna want to know if you want to know all articles about Tesla from the last month, sorted by recent first, then this is our URL. And this is what you're gonna do GET request to. One thing you guys see about this, HTTPS, S is secure. This basically uses, I think, TLS SSL to hash whatever request we do so that, you guys can't intercept it. Even if you guys do, then you guys can't read what this request is. Anyways, that's what secure is. And then this is the URL, so the newsapi.org. And this is the endpoint. You want to go to slash everything. This question mark is what you guys call a query. Oh, is it a filter? I think it's a filter. And then so what it's saying is this Q stands for ticker. Ticker is going to be the Tesla. And from, June 8th, sort by, publish that, and API key. So reason we want to do secure is because we don't want others to use our API key because if I were to pay for it, like this API key, then I wouldn't want you guys using it as well, right? Anyways, what else? Right. So this is a query. So it's filtering by all of these. And for every filter method, you usually do ampersand. And then here it says what the return status would look like. So as I said, whatever that you guys remember the stock equals YF the ticker or ticker. Then Y finance would also have something like, okay, if you do this, then you will have something returned like this. Here it's saying, okay, we're gonna have a key called status, and it will tell you if it's okay. You will have another, okay, why is it? You'll have another key called articles, which has a whole bunch of articles with each a source, author, etc. But that's basically what the API is saying. Is it like pirating if many people use the same API key? Would you? I think it's different because pirating, you only buy it once and then share it to a lot of people. So the only risk is like you going to jail for pirating or like not pirating, but selling that pirated video or movie to others. But for the API key case, every time you use the API key, you get charged. So I don't know if you would want to give it to other people who will use all your money, if you know what I mean. Yeah. So basically, this API key, usually the company or well, Yahoo Finance is free, but like let's say some company sells their API key and charges you. But then you could just charge people. Yeah, but why would they pay more for yours? Because you would want them to pay more than whatever you pay for it. Why don't they just go straight to the API key, right? But yeah. Mm. Or another thing people do is make an app using multiple API keys, like multiple APIs, since that, let's say some weather app or something, it uses a location API, it uses a weather API, and it's used as this app that kind of brings all these APIs together for this user to see all these features in one place. That's what people usually do. And then they upcharge it because they're using all these APIs and they want to make profit out of it, etc. What else? Nothing. Okay, Kaden, can you share your screen again? I don't know if this is interesting to you guys though. Okay, let's do response sequence. Enter new line, data equals response.json. So you did this HTTP.get. You got the response inside response. Now you want to extract the data. This is basically these steps are basically all you do for like it's like copy and paste for all these server side API requests. Okay, you get it, you put it into response, you do data equals response.json. You're parsing that response as a JSON element. JSON is a function, so you need the circle bracket. But yeah, basically it's saying, okay, now we got the response. Now we want to parse it. So we're gonna do data equals response.json. Delete the D. Next line, you don't need anything in the JSON. You're gonna do return, and you're gonna return it like before. You're gonna do a list. Inside the list is a dictionary. Inside the dictionary is title. So quotation mark, title, and then colon, colon. You're missing a colon. Yeah, colon. Sorry. Colon as in colon. And then to the right of the colon, you're going to do d.get. So it's going to be like before, right? The d is going to be a later on, we're going to do a for loop. And the d is going to be a single instance of some data inside response. So you're going to do d.get. Get is a function. Inside the function, you're going to do a quotation mark for a string. Inside the string is going to be headline, comma, outside the string, comma. Still inside the circle bracket though. Empty string. Yes, that's it. And then to the right side, you're gonna do publisher. So another string, publisher, colon, d.get, function, quotation mark, source, and then comma, empty string. And then you're gonna do another one, title, publisher, now link. and then do another colon, uh, d.get, and then string URL, comma, empty string. Yep. And then still inside the list, but outside the dictionary, do enter for D in data, for D in data, for D in data. You're gonna do for D in data, and then another list, but it's gonna be a indexing. So inside the list, you're gonna do colon 5. So we're getting the first 5 data. Next line. Backspace. Now you're gonna do the accept. Accept, exception, colon, enter. You're either gonna print it or you can just do pass here. Yes. Now, for, okay. Do tab if space all caps use API underscore key colon try and then so it's a try except block try. You're gonna do response equals underscore HTTP dot get. I'm gonna just paste the URL. You're gonna do return response.json. And then to the right side, do dot get uh quotation articles. To the right of the quotation, but inside the circle bracket, you're gonna do comma list. Yep. To the way right side, you're gonna do another list, but it's gonna be an index. So you're gonna do colon 5. Sorry, outside the circle bracket. Yeah. Uh, yeah, that's better. And then do enter next line. Backspace. You're gonna do accept, exception, and then pass again. You forgot. Yeah. Enter. Go to the line of the if after pass. Yep. You're gonna do return. You're returning a list which has a dictionary, which has a string called title. You're gonna do another string. You're gonna do no APIs are available. comma, publisher, string publisher, colon, system. And yeah, that's it. You can stop sharing. Okay, so the data client is good. Okay. Um, so I guess to main. No. Helpers. Sure. Okay. Let's continue on with data. Okay, let's do helpers next. Nicholas, can you share your screen? And James, you'll be next, so just be aware. Okay, parse data first. So you're gonna do for format in formats. You got it the other way around. Yep. So reason why or how you would know, you can see above that that formats is a list of four formats. So you're going to do each format inside of the formats. That's confusing, but yeah. Anyways, for each format, you're going to do try and except block. So you're going to try, colon, return, date time, delete the circle bracket, datetime dot strp time strp. No A, no A. Time, basically saying strip it, strip the time. And that's a function, so circle bracket, date underscore string, date underscore str. That's one of the arguments of parse data, comma, format. And so next line and the try except, except, no, no, no try. We already have the try. No, no, go back. in the same line, yep. Except value error. No, right side of except. And doesn't need a circle bracket. Yep, but needs a colon. Pass. Enter. Backspace, backspace. Return none. 1 second, guys. Let me open my window. It's getting too hot. Okay. Next function, which is let's do go all the way to the bottom. Safe divide. We'll just do that first. Delete the pass. Return numerator divided by denominator. If same line but space. If denominator does not equal 0. Else default. Same line. Space else default. Yep. And then you can let's start sharing. Okay. Okay. Format currency. Basically, format a larger number into a human readable currency string. If the value is greater than 1 billion, then show x dot xxb, which is like 1.11 billion, b as in billion. If it is greater than or equal to million, then show 1 point blah 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 million. If it is greater than or equal to 1000, then show blah 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 k. Otherwise, just show the money. Make sense? Here we do if the absolute value is greater than or equal to blah blah blah. Because we also want to do the same for negative money, right? So if it's like negative 1.11 billion, then we want it to be like that instead of negative 1111, I don't know, like 7 digits or something. No, 10 digits. Anyways, like that. So if it is greater than 1 billion, then we want to return a F string where we have the symbol, and then we want to do the value divided by 1 million. And then you want to only cut off so that you only get 2 decimal places, which is why we have like 1.12, let's say. This makes it so that we only have 2 decimal places. Here we do billion, million, thousand, or else we just return it. No questions there. And we have sanitize file name. Replace any character that is not a letter, digit, etc. We're going to do RE, which is regex, I think, is the library. RE, the regex, has a lot of regular expression support. So things like, subtracting, so like removing characters, adding characters, finding characters, replacing characters, etc. So here we're doing subtracting. So we want to, if you guys hover on it, it says we want to return a string obtained by replacing the leftmost non-overlapping occurrences of a pattern. So basically, for each pattern, you want to replace it with a replacement character. Here, we're replacing everything with an underscore. What are we replacing? Anything that is not a letter, etc. And basically, we're replacing everything inside the name of the file name. Next, time frame 2 days. The reason I'm doing this for you guys is because I don't see any reason that we need to do this or that I need to make you guys do this. Basically, convert a Y-finance time frame string into an approximate number of days. So basically, just so this is a dictionary. You're doing an O of one lookup to get the time frame. O of one, what does that mean? You only look once. You don't have to check is one, let's say you're looking for 5Y. In a list, you would have to go, okay, 1D. Does 1D equals 5Y? No. Does 5D? No. 1 month? No. And then you just keep going until you find 5Y. So the lookup time is O of n. You have to look through all n elements to make sure that 5Y is not in this list. But this is a dictionary. If you hover on mapping, then it says mapping is a dictionary. It maps strings to integers. String is the key. Integer is the value. You guys can see it here, right? 1D is a string. 1 is an integer value. It's being mapped. This dictionary has a lookup time of O of 1. Basically, if you look for 5Y, is 5Y inside of mapping? Yes. It will tell you right away, yes. Is 100Y in this mapping? No. It will tell you right away. If you had a list, you would have to look through everything to find out that 100Y is not there. The reason why mapping is so fast, does anyone know? Anyone know what makes dictionaries different from lists where it doesn't need to find for each and everything to find out that it's not there? No one? Basically, you assign stuff in dict. In a way, yes, kind of. You'll learn this later, but dictionaries have this whole logic behind it where think of it as buckets, and basically it's mapping every key to its own bucket. So if I share this, so hash map is a dictionary. Basically, hash maps have this hashing logic where let's say you have James and you want to add it to this hash map or dictionary. Then you pass it through hash function, which gives you a set of strings. Let's say 555 1 2 3 4 2 5 1. Let's say that this equals James. James is represented by this 9 or 10 letters. I mean, numbers. How you guys can do this? Let's say really like a random hash function is like, oh, James. Let's do like strlen. Oh wait, that's C. What's yeah, len of let's say James. And that should be like what, 5? Then like you multiply it by like 35 and then divide by 11 and somehow you get 555 1 2 3 4 2 5 1. That's the hashing logic. Now each of one of these you're gonna say, okay, this number is going to get mapped to this 0, 1 bucket. You only have 7 buckets here. A good hash function maps everything into one bucket. Sometimes you get hash collisions, which you solve by doing like secondary hashes, like stuff like that. You don't need to learn that. But just know that that's the reason why. Okay, that's how you map them into the buckets. Now, how you look them up O of 1 is using that same hash function. So you just run it through that hash function and then you get that location because that's where it is, right? But yeah, that's how it works. And then James, do you want to share your screen? I think we'll do PDF report next. No. Let's do models next. So we're going to do LSTM predictor. LSTM predictor. Basically, LSTM prediction model is something called long short-term memory networks. So it's basically a neural network to process sequential data. Any words that you guys don't get? We already work with neural networks, right? Sequential data, which means like one after another. So like 1, 2, 3, 4, 5. That's sequential. Why is it sequential? Because stocks are like sequential, you know, it's like every second the price changes. And yeah, basically we're doing our recurrent neural network that kind of bases it off the sequential data that we have. So, first thing you want to do, let's go to line 47, normalize. So 49. Delete the pass. So basically this function is used to normalize a list of prices to the range of -1 and 1 using min-max scaling. Return a normalized array, minimum value, maximum value. If all values are the same, then avoid division by 0 by making max equal minimum plus 1. Okay, normalizing is used a lot also in like picture AI, like AI analysis, or like what do you call it? AI generation of pictures, or like uh what do you call it? Inference on pictures. So let's say you're doing like some AI security camera. All the images you get, you would run it through a normalizer to remove all the colors. Now, how does this relate to normalize? Normalizing puts everything into a range of -1 and 1. Pictures inside your computer is represented by 256 RGBs, right? You guys know what RGB is, right? R is represented by 256 uh, pixels, or range of that one pixel of red. Yeah. So it's 255, comma 255, comma 255. That's all the possible red, green, blue. 255, if you guys think about it, do you guys know? So 255, so 0 is also counted. So that's 256 number of reds that we can have. If you guys, that's 8 bits because every bit is 2, 0 or 1, right? 2 to the power of 8 is actually 255. I mean, 256. So basically, all pixels of red, green, blue is represented by uh 24 bits, 888. So just something that you guys can think about. That's the reason why it's 256, because we want to kind of represent red, green, blue in a like something that the computer can understand, and we want to maximize, like we don't want it to be like 250, right? Then we're missing out on six values that we can have, right? But yeah, anyways, that's something. The reason we want to normalize it is because we want to change that RGB into just black and white, which is why -1 to 1. Let's say like negatives being black, one positives being white or something. Anyways, let's do ARR array equals NP as numpy dot array, and that's a function. Inside the function, you're gonna series, comma, D type, as in data type, data, D type equals NP, which is numpy, dot float 32. Yep, like that. Dot reshape. No, to the right, to the yeah, reshape -1 comma 1. So as you can see here, you're doing a numpy array of the series, which is passed in. It's a list of float values. You're gonna say that to this array, you're building this numpy array. You're saying we're gonna pass in the series, and this series is a list of floats, float of 32-bit floats. That's what 32 means. It's a 32-bit float. And you're reshaping it to -1 and 1. That's what normalizing is. Now you want to add the logic for if all the values are the same. So you're going to do mn, comma, mx equals arr dot min function, circle bracket, comma, no, delete the function, comma, outside, comma, like to the right, comma, arr dot max, same thing, function. And then next line, you want to do if mx dot mn equals 0. Not dot, minus, right? You're gonna try and see if they're equal. If it is 0, then that means it's equal, right? So you want to do return arr comma mn comma mx plus 1, right? If they are the same, then you want to do max is plus 1. Delete the elif. You're gonna do normalized equals. So this is the instance where max and min are not equal. Normalized is going to equal circle bracket, circle bracket, arr minus mn. To the right side, divided by circle bracket, mx minus mn. Right side times 2 minus 1. Enter. Return normalized, comma, float of mn, comma, float of mx. And let's just do one more. denormalize. You're gonna do return. It's really fast. Return, circle bracket, normalized +1. Divided by 2, right there. Outside it, you're gonna do times circle bracket mx minus mn. Outside of it, you're gonna do plus mn. Okay, you can stop sharing. Okay. Any questions, anyone? Does everything make sense? Okay, let's move on to some Blookit. Let me stop sharing though. Okay.